All right, part two, starting with number 4. Just obviously we're back to graph and sine and cosine. See if you guys can make the necessary changes. So a couple formulas. Amplitude is the absolute value of A. The period is 2 pi all over the absolute value of B. We'll talk about that in a little bit. So those are the things you kind of have to have in your toolkit just to get started. So as you can see, we're focusing on cosine to get started. I like to go a little bit to the right and a little bit to the left, and then make necessary adjustments from there. All right. So we start by asking ourselves, what does the parent function y equal cosine of x look like? Like I said here, it goes over. So it goes from 1 to 0 to negative 1. From 1 to 0 to negative 1. It's like a little hat. Now we're going to go little step at a time. What does that do? Well, that flips it. So that's going to look like that. One step at a time, guys. And then this doubles the amplitude. Now notice the formula. The formula says amplitude is the absolute value of A, which that's the reason for the it's actually negative 2. Which would make it a 2, but that's kind of overkill, because if the original amplitude is 1, which it was, it's just doubled. So now this guy is going to go up to 2, call that 2. That's going to go down to negative 2, and call that 2. These zeros stay, because 2 times 0 is 0, and we're to there. Now things are going to get a little dicey. I could move it up 5 right now, but I'm going to focus in here. Now what you need to know is there's an invisible 1 there, and that's our B. B is 1/2. So that's going to turn into, and notice the original period is 2 pi. It goes from pi this way to negative pi that way. That's a total of 2 pi. That's our normal period. And so now it's going to change. It's going to be 2 pi all over 1/2. Well, when you divide by a fraction, you multiply by the reciprocal, so it's 4 pi. So 2 cycles, I'm not going to be able to fit it on there, so I'm not too worried about that. Because now I need, if 4 pi is my entire period, then I need 2 pi on one side and I need 2 pi on the other. So this needs to go out to 2 pi, and then this needs to go out to negative 2 pi. So that guy needs to come here, that guy needs to come here, and basically this is going to get horizontally stretched. So I'm going to go ahead and make this orange, show all my work, and now what that means is I've got a new wall here and a new wall here. I'm taking this pink one and I'm stretching it. So that's going to look like this. Now, one thing I didn't mention was the pink guy comes through the x-axis halfway here, and so halfway between 0 and 2 pi is pi. I just went through there on purpose. I went through there on purpose. That's the halfway mark between 0 and 2 pi. So that's it. And there really wouldn't be enough space to do another one over here, so I'm going to stick with 1 cycle. But I'm still not done. I got to bump that guy up 5 units. So we'll use this finally. So this is up 2, so I gotta go add 5 to that. 3, 4, 5, 6, 7. And this is gonna go at negative 2, so up 5, there'd be up 2. I know this is kind of wonky, but there. And then there'd be another matching guy right there. So it's not gonna look perfect because my units aren't perfect, but that's it. Okay. Let's go on to sine. Well, we got to get started by knowing what sine is. We also should know that this is pi over 2, pi, negative pi over 2, negative pi. And you can see b is 1, so our period's going to stay the same, because 2 pi all over 1 will just be 2 pi. So we got to get our parent function nailed. So we know it goes through the origin, up to 1, back to 0, down to negative 1, back to 0. There's your parent function for y equals sine. What does that do? Well, it's going to triple the amplitude. So this guy is going to go up to 3. This is going to go down to -3. And that's my first step. Now I'm going to do my second step. This needs to move to the right 1 chunk, or pi over 2. So that guy moves here, this low point moves here, that moves here, so I know that goes to here, that moves here, and that moves here. So it goes up and it comes down. And then final step, move that whole thing down 1. So this goes down here, this goes down there. And once you kind of get the feeling, you can kind of just go with it. It's going to go here and here. So we bumped it down 1. Perfect? No, but I've communicated the point. Okay, so back to old school stuff, not letting go of these piecewise functions. This must be important, must be on your exam. So now it says graph f of x. Well, that's this whole thing. That means we have 3 different graphs with 3 different domains. So let's take number 1. Y equals -3x plus 1 in this domain. Now x is less than -1. Don't start at -2. Start at -1. Just tell yourself it's going to be an open circle. And what's another number less than -1? Let's go -2. And this is a line, so we only need 2 points. Well, -1 times -3 is 3, plus 1 is 4. -2 times -3 is 6. 6 plus 1 is 7. So I got -1, 4, right here with an open circle. -2, 7 would be right here. And I know that's going to go up and up and up and up forever like that. So I've taken care of this one. Now I look at this and I can see it's a parabola. Plotting 2 points is kind of dangerous. So let's go ahead and take a look at this and go y equals -2x squared plus 4, and let's use our noggin a little bit. But it can, x is greater than or equal to -1, so I'm going to start with -1 with one of these, less than 1 with one of these. So I got to remind myself, close dots, important little details. Well, let's plug these in. -1 squared is 1, times -2 is -2, plus 4 is 2. Put a 1 in. 1 squared is 1, 2. So I go -1, 2. I go 1, 2. And I'd be mistaken to just connect those dots. We have to remember a few things about this. Back from Algebra 2, this flips the normal parabola, so it's going to be a sad face. We also need to know that our y-intercept is where x equals 0, and it fits in between -1 and 1. And if I put a 0 in here, it cancels this, and it's 4. So my y-intercept would be 4. So really it's looking for that little piece of the parabola. Right there. Kind of dangerous. 0, 4. Got to remember that third point. And then we've got another line, so life gets good again. And then x is greater than 1. Start at 1 with an open circle, and then pick a 2 or a 3 or a 4, something bigger than 1. 3 times 1 is 3, minus 2 is 1. 2 times 3 is 6, minus 2 is 4. So 1, 1, open circle, 2, 4, and then I know it goes on and on and on. That's gonna, I don't know if that touches that or not. Looks like it misses. Yeah, it misses, goes under. And there we go. Is it continuous? No. How do you know? Because there's breaks. I don't know how else to explain that. Evaluate f of -1. Well, first of all, we got to find out where does this even fit in the domain. This is x is less than -1, so it's not that one. This is the only one it fits in, because this is x is greater than 1, and this is definitely not greater than 1. It fits in here. So it's just saying plug -1 in here. Well, -1 squared is 1. We already did this. Interesting. Times -2 is -2 plus 4 is 2. That was one of our points right here. All right, on to the trig. So here we go. This is saying how far do you have to spin your spinner, kind of think of it as theta, to create this story. So we got to treat it like a math problem now. So 2 sine of some spin equals 1. Divide by 2, divide by 2. These problems should be getting very familiar with you now, to you now. And this does say keep it in the positive spin realm, no negatives. So this is our opposite side, this is our hypotenuse, but there's a sneaky little clue. Sine is positive. So I'll do my work up here for that one. All students take calc. Where is sine positive? Not here, not here. How can my opposite side be 1 and my hypotenuse 2? That would look something like this, making that a 30. And then it would also happen over here. That's a 1, that's a 2, making that a 30. But the question is, how far do you have to spin your spinner? So they want to know, how far do you spin your spinner to get there? Well, that'd be 30. How far do you spin your spinner to get there? That'd be 150. So those are our two answers. 30 degrees and 150 degrees for that problem. Let's go on to this one. Subtract 1, subtract 1. This is going to be kind of a weird one. It's asking, where do you spin your spinner to get your adjacent side over your hypotenuse to equal -1? Well, remember, your hypotenuse is always positive. Your adjacent now needs to be negative, and the adjacent has to equal the hypotenuse. Where can that happen? Well, this is one of those weird ones. I always like to start at 0 degrees just to get my brain clicking here. Here's my adjacent side and my hypotenuse, and this is my opposite. Notice my adjacent side and my hypotenuse, they're definitely equal, but it's missing the negative. So I'm like, wait a minute, then maybe that happens over here. And that is correct, because that's negative, that's positive. These things are considered equal at 180 degrees, and that is your only answer for that problem. Okay, now for some transformations. So it's saying if f of x is this crazy looking thing, what does this do? Well, that's simply saying move it right 1 and up 4, just a different way of saying it. So every single point moves right 1, up 4, right 1, up 4, 1 right, 1, 2, 3, 4, 1 right, up 4, 1, 2, 3, 4. I'm just going to kind of get my, this point goes right 1, up 4. This point, right 1, up 4. This final point here, I'm just going to say, well, actually, just kind of copy it. And this is going to go like that. So, best to my ability. All right. This negative is going to flip it over the x-axis, and when you have a situation like this, anything positive becomes negative, anything negative becomes positive. And so my first step would be to just go like this, and this, kind of this, that goes here, and then straight down. And now every point gets, the amplitude gets doubled. So this is kind of crazy, but that peak is 1, now it's going to be 2. This has a certain slope, now the slope is doubled, so it's going to come down sharper. And this is -1, so it's -2. Kind of takes care of itself. This is 1, so now it's 2. And then this angle is going to have to be super sharp because vertically stretched. All right. Well, I can see why they gave us a third graph over here, because this is a mess. So I'm going to try to copy it. Give me a second. Okay, so obviously these boxes are a little wider than these boxes, so it doesn't look perfect, but it's been moved from there to there. So this is f of x. So what does this say to do? That says triple the amplitude. So one step at a time, we'll make that red. It's dangerous because I'm using ink. But if that's -1 times 3 is going to be -3. That stays the same. That kind of takes care of the amplitude too. That one is times 3, and then that one is now -3, and this is just going to come screaming up a lot faster, 3 times as fast. But now we got to move that whole thing left 2, down 1. So if I dare, I'm going to do everything in one motion. So that's a key point. Left 2, down 1. Left 2, down 1. Connect. And I know this is going to go parallel to that red line. And, 2 down 1. Okay. This guy, left 2, down 1. And yeah, there we go. Good. All right. Law of sine, law of cosines, area of a triangle. Well, every picture tells a story, so let's get this thing drawn a little bit. There's an obtuse angle. So we know angle B is 110. I'm just going to randomly connect these. My drawing might not be perfect, but angle C I'm going to put right there. 38 degrees, 110. Now, as you put stuff down, you should be thinking, because it says solve the triangle, which means find any missing angle, find any missing side. And so notice angle A is missing, and that should be the lowest hanging fruit ever. So add this to that. It's 148. Subtract that from 180, and we get 32 degrees. And that's probably going to be helpful. And then it says side C, remember side C is always opposite angle C, is 13. Find the area of the triangle. So we've got these formulas. I'm going to hit pause here. So as you can see, we've got these 3 formulas, and if it's a really easy problem, all this information is already there for us. Now notice we've got side C, so it looks like we could use this one or this one. But notice, if we use this one, we need side B. If we use this one, we need side A. So you still aren't ready for this yet. So we're going to have to use the law of sine or cosine. Use the law of sine when possible. So we're going to go sine of angle C all over side C. And I'm going to go ahead and just randomly pick angle A. So sine of angle A all over side A. So definitely make sure you're in degree mode here, and I am, so that's good. And so here we go. Sine of 38 is 0.139. Sine of 32, 0.53. I'm going to round a little bit. Remember, we cross multiply now. Times 13, 6.89. So 6.89, we're going to multiply that way, 0.139a, divide by 0.139, 0.139, so divide by 0.139, and we get 49.56. So A, we'll just round to the 10th, 49.6. All right, so we know this is 49.6. I guess this is 2 questions. Solve the triangle and find the area. Well, we're ready to find the area now because we got side A, side C, and angle B. So we'll stuff it in there. So 1/2 side A, 49.6, times side C, which is 13, times sine of angle B, which is 110. So all these things multiplied together. So I'm going to go sine, I'm going to do backwards, sine of 110 times 13 times 49.6 times 0.5. So we get approximately 300 and, let's just round it, 303 square inches or feet or whatever units. But we're not done solving the triangle. We still need to find side C, or excuse me, side B, Can't use Pythagorean theorem because you need a 90, so you're going to have to use law of sine again. So we're going to go sine of angle B over side B. And I'm going to go ahead and use these units again, using sine of angle C over side C. So it's 0.139. I'm just stealing that information. So here we go. Sine of 110 times 13. We get, so I'm multiplying that way, 12.21 equals 0.139b. Divided by 0.139. 0.139, and B is approximately 87.9. There, we solved the triangle and we found the area, and this is a good place to stop this part 2 video. These problems are long. Alright, hang tough.